Most enterprise agentic AI pilots never reach production, not because the technology fails, but because the architecture does. If you're a solutions architect or automation engineer watching your AI proof of concept stall before sign-off, this checklist shows you exactly where the gaps are. Today, we're walking through the enterprise agentic AI deployment blueprint that separates automation which scales from demos that die in staging. Here's the core problem. Organizations run AI agent pilots in clean sandbox environments, then push toward production systems with real data volumes, approval chains, and compliance requirements, and the agentic AI architecture collapses. The failure isn't the LLM, it's the orchestration layer, the memory design, and the missing fallback logic around human-in-the-loop handoffs. The architecture we're building is a multi-agent orchestration system with a supervisor agent routing tasks to specialized sub-agents, a persistent memory layer, tool integrations across enterprise platforms, and a full audit trail. The stack uses LangChain for agent orchestration, OpenAI GPT 4.0 as the reasoning engine, Pinecone for long-term vector memory, and Make for connecting downstream business tools. Data flows from a trigger source, Salesforce, ServiceNow, or a webhook, through the supervisor agent, which classifies intent and delegates to the correct sub-agent. Every decision node writes to a structured audit log in PostgreSQL before any action is executed. Step 1. Define your tool registry explicitly inside LangChain's tool interface. Never let an agent infer what tools are available. Enumerate them with strict input schemas. Step 2. Configure your context window budget using LangChain's token trimming utilities. For GPT 4.0's 128K window, reserve at least 20% for output and reasoning. Step 3. Connect Pinecone as your long-term memory store, using namespace isolation per tenant or per workflow to prevent context bleed between enterprise clients. Step 4. Build your supervisor agent in LangGraph using a state machine pattern so each node transition is logged and replayable. This is what your compliance team will audit. Step 5. Integrate your first sub-agent, a data retrieval agent pulling from Salesforce via Salesforce REST API with OAuth 2.0 token refresh handled in a dedicated middleware layer. Step 6. Add a document processing sub-agent using LlamaParse to extract structured data from PDFs and route results back to the supervisor with a confidence score threshold. Step 7. Wire human-in-the-loop checkpoints using Slack's BlockKit API. When an agent confidence score drops below 0.75, the workflow pauses and posts an approval request to the designated Slack channel. Step 8. Connect your output actions through Make, mapping agent decisions to CRM updates in HubSpot, ticket creation in Jira, or notification triggers in PagerDuty, each action wrapped in a try-catch with a dead letter queue in Redis. Step 9. Implement your audit trail by writing a structured JSON event to PostgreSQL at every state transition, capturing agent ID, tool called, input hash, output hash, latency, and the approving user ID when human review occurs. Step 10. Run load simulation using Locust to stress test the orchestration layer at 10x expected production volume before any enterprise sign-off meeting. The most common failure point is context window overflow under real data loads. If your Pinecone retrieval returns more tokens than your reserved budget, the agent will hallucinate or truncate silently, so enforce hard token limits at the retrieval layer before injection. The second failure is broken human-in-the-loop handoffs. If your Slack approval times out with no fallback path, the workflow hangs indefinitely. So configure a 24-hour timeout that escalates to email via SendGrid automatically. Never deploy without testing your dead letter queue. Redis should capture every failed action so operations teams can replay or triage without data loss. From here, you can extend this blueprint by adding a self-evaluation subagent that scores output quality using an LLM as judge pattern, giving you continuous observability in production. You can also layer in Langsmith for full tracing and prompt versioning, which is the observability infrastructure most enterprise compliance teams will require before final approval. All tools and documentation referenced in this video are linked below. If this breakdown saved you a failed deployment, subscribe for more enterprise automation blueprints.